Hello, I'm David Silver from Udacity, and this is the 9th lesson of the Udacity Self-Driving Car Engineer Nanodegree program. It's called the Traffic Sign Classifier project. This is the Traffic Sign Classifier project. You just finished getting your feet wet with deep learning. Now put your skills to the test by using deep learning to classify different traffic signs. So this lesson is all about leading up to image classification of a data set that consists of 43 different types of German traffic signs. It's actually called the German Traffic Sign Recognition Benchmark data set. It's a somewhat famous data set for deep learning. And we start off the lesson by walking you through what the project's going to be, and then we walk through Linette, the architecture of Linette. This is something we actually introduced in a previous lesson, but in this lesson we go through the Jupyter notebook that we use to build and train an implementation of Linette using TensorFlow, and we highlight a lot of the different elements of Linette. In particular, we go through this architecture here, various convolutional and pooling layers, followed by 3 fully connected layers at the end, and we describe exactly how TensorFlow implements Linette so that you can turn around and use Linette or something like it to classify traffic signs. Another thing we do in this lesson is we walk you through how to set up an EC2 or a GPU-enabled EC2 instance. EC2 is Amazon Compute Cloud. It's part of Amazon Web Services. It is essentially a way to spin up a virtual server, and in particular, we're interested in a virtual server that has a GPU attached because GPUs really accelerate the training of deep neural networks. Our friends and partners at Amazon Web Services Educate have provided free AWS credits for students in our program, and so you can use those to spin up an AWS EC2 instance that has a GPU attached, and we walk you through all the different steps you need in order to get your high-powered GPU server up and running. Once we have that up and running, we walk you through in more detail how to use the Jupyter notebook to build and train Linette. We show you how to do that on an AWS EC2 instance, so you're doing it in the cloud. You're doing this deep learning training on AWS in the cloud on a GPU instance. If you happen to have a GPU, an NVIDIA CUDA-enabled GPU on your local machine, then you can actually skip all of the AWS parts and just do the training locally. And in some ways, it'll actually be a lot easier. But we know a lot of students don't have that or don't have that set up, and so we provide instructions and credits to do that training on the cloud using AWS, which is terrific. And then once we've trained Linette, then the next thing to do is to apply it to the traffic sign data set, and so we actually walk you through how to take the Linette instance or model that you have trained for MNIST. We start out training it for the kind of world famous MNIST data set, which is a data set of handwritten digits 0 to 9, and then we repurpose that data set to train a traffic sign classifier. And the project is actually to train that traffic sign classifier, see how accurately you can classify traffic signs, and then submit your model to the human reviewers in Udacity's review network, and they'll give you all sorts of pointers about what you might do to improve or push your network forward, or if you haven't quite hit all of the rubric points for passing the project, they'll help you get your project passed as well. So that's the second project in the Nanodegree program, the Traffic Sign Classifier project. It is a really fun project, particularly if this is your first time working with deep neural networks. It's really magical to watch your network train and start to classify traffic signs. And it's one that's obviously quite pertinent to the real world and to self-driving cars. So it's pretty exciting. The Linette Lab from the Convolutional Neural Networks lesson is a great starting point for building a network to classify traffic signs. But before you adapt Linette for the project, Let's walk through the lab solution and review what happens on each line. This first cell in the Jupyter notebook shows the original drawing of the Linette architecture from Jan LeCun's 1998 journal article. The network takes a 32 by 32 image as input. Then that image goes through a convolutional layer, C1, followed by a subsampling layer, S2. Since Linette was originally designed, subsampling layers have mostly given way to what we now call pooling layers, which is actually what we use in this lab. Then there's another sequence of convolutional layer, C3, followed by a pooling layer, S4. Finally, there are 3 fully connected layers, including the output layer at the end. That's the architecture of Linette. The rest of the notebook implements this architecture in TensorFlow. Cool. So that is the 9th lesson of the self-driving car engineer nanodegree program. It's called the Traffic Sign Classifier Project. It is a really fun way to get started with deep neural networks. And as Sebastian likes to say, you don't lose weight by watching other people exercise. In order to become a self-driving car engineer, you have to write the code and train the models yourself, and this is a terrific way to get started. If you're interested in learning to become a self-driving car engineer with us, you can visit udacity.com/drive to apply and sign up for the Nanodegree program. Hope to see you in class. Bye-bye.